All right, so welcome. This is Developing and Using Models Using Digital Tools. My name is Rebecca Gorelli. I'm the Science and STEM Specialist here at the department. But also we have a very special guest named Robin who is going to come into this space, and I'll read her bio in just a second. So Robin is a fabulous educator who has been teaching for 9 years in the Amphitheater Unified School District. She taught a variety of grades, including a 4-5, 4th and 5th multi-age class, K-6 gifted, and currently 5th grade. She has a certification in elementary ed, K-8 and 6-12, but she's specialized in STEM. She is also the 2017 Arizona Science Teachers Association Elementary Science Teacher of the Year and the 2020 Presidential Award for Excellence in Math and Science, Arizona finalist for elementary, which is a very prestigious award, very amazing honor. We are so grateful for Robin being here with us today. So come on in and say hello, Robin.
Hi, thanks for coming and thanks for spending your Tuesday afternoon with us.
Yes, thank you. All right, so we are going to use the chat box a lot. Please make sure it's turned on to everyone. You can stay unmuted until the end, which we do usually have some time for Q&A. And you do not have to have your video on, except for if we go into breakout rooms, it might be nice to see your face. So thank you for that. And now that you know who we are, let's see who is with us. We would love to know who you are, what position you're in, what county you're in, and curious to know how you heard about this PD. So take a moment, find the chat, and introduce yourselves.
Awesome. So we have a 4-5, 4th, 5th grade teacher. Okay. Pima Community College. 7th grade science teacher. Awesome. 7th grade science teacher. Hello. Mountain, Maricopa County.
Good. Somebody's using the newsletter. Thank you for that. I really appreciate that. Awesome. All right. Well, let's keep, I'm just going to gently push us along. Keep introducing yourselves in the chat. We are going to be using this thing called a webinar resource dashboard. And that is the link that I keep putting into the chat. So I'm going to put it one more time. And all you're going to do is click that link, make a copy of that document, and this is going to be the document we use for this entire experience. And so what it is basically a one-stop shop of everything you're going to need. So at the top, our names and emails, links to our Arizona Department of Ed Science Standards page, our resource page, and our registration for webinars. The slide deck we're using today is right here for you. It's a PDF, so you do have these slides. And so you can see on the left, we have these numbered. And so as Robin is teaching you today, she is going to call out, hey, this is resource number 3. Go ahead and open that. And the way you're going to know is she's just going to call it out. And the ones that are colored in gray are the ones we are literally going to open together in this space. The ones that have a white background are ones that are just links of resources we use to develop this experience. So just additional resources for you to read whenever you want. So let's just make sure everybody has this document up and ready to go. And the way we know you're ready is just put done in the chat, a little informal assessment here. Thank you. 1, 2. Okay. And honestly, the best way to engage in our webinars these days is to, because they're very highly interactive, is to try to have, if you can, shrink the Zoom screen. If you're working off of one screen, shrink it down and shrink your Chrome or whatever browser you're using. And so you can look at both at the same time, if that works for you. Otherwise, you're just going to have to toggle back and forth, which I know can be a little overwhelming. But this is the world we live in, and this is the digital age, and we are working in this digital space and using digital tools today. So this is how we're going to have to do this. So I hope you're with us. We're here to help you if you need help. All right, thank you for all those dones. I feel like we have most folks ready to go. And I just want to give you a little background that we do offer a ton of different webinars that are kind of at different levels. And where we are today is in this second sort of pathway where we are going to assume that you have some basic knowledge of the 3 dimensions. This is not a beginner webinar. We're going to be using the 3 dimensions and hoping you have a foundational understanding about the 3 dimensions. This is more about instructional practices. So if you want to come take another webinar with us, that would be great. This is sort of in what we call pathway 2. And the award that Robin was a finalist for, congratulations, Robin. This is the award. It's called the Presidential Award for Excellence in Math and Science Teaching. And right now, the way it works, every year there's a different cycle. So this year it's K6. Last year it was 7 through 12 and so forth. So it changes. Right now, the nominations are open, and since you do have a PDF of the slides, you will have this hyperlink. So you can apply for yourself, you can nominate a colleague. Just know that it will close in January for nominations for other folks. And if you yourself want to apply for this prestigious award by February 6th, and it comes with a $10,000 prize, and you get to go to the White House and meet the president. So it really is the Presidential Award. So I'm just going to invite you to read over our goals for today. And so as you can see, we're going to be working in this approach called Gather, Reason, Communicate that Robin is going to explain very, very explicitly and walk you through it. And we will be discussing science engineering practices and 2 cross-cutting concepts. So let's get started. I'm going to stop sharing. I'm going to hand it over to Robin. Robin is going to be your facilitator, and I will be your helper on the side. So Robin, come on in.
All right, thank you. Let me just share my screen with you. All right, so the lesson that we are going to be engaging with today is coming from resource number 3 on the dashboard. It is a marvelous website called Going 3D with a GRC. There are lessons for elementary, middle, and high school. So it's a one-stop shop, and you can just pick what grade band you're in. If you do click on it and you do open up in another window, you'll see that this is a 5th grade lesson, and the videos and the slides, some of them I modified to use in my classroom, but all like the heart of this lesson is coming from the Going 3D with the GRC website. So why are these lessons so special? Why are we using these? It is because it is all about performances, and it's all about how we want students to perform in our classroom, especially in science. So as we make our way through the lesson, you'll notice that we will have a group performance first. And during that group performance, we'll be working together in small breakout groups. We will be thinking about what causes some stars to appear brighter than others. We will obtain and evaluate information that we will be gathering from a website called Stellarium. We will be analyzing data, and then we will be developing a model in small group. And all of these things are group performances, so they are meant to be done with a group of kids or with a group of adults, as we will be doing today. The second piece of this will be a group performance. It is a discussion. So you will be constructing an explanation as to how the scale of the distance to stars affects the apparent brightness of those stars. And then last but not least, the third performance will be an individual performance, which we will not be doing this part today, but I will talk a little bit about it at the end of our webinar. And this really gives the students the chance to develop in their individual performance. So really show what they know after they have worked with a group, with their peers throughout the entirety of this lesson. And one important thing that I do want to talk about with these GRC lessons and their performance standards is that when you look at this slide and you're seeing all of the blues, so you're seeing the ask questions, analyze data, develop a model, construct an explanation. Those are all science and engineering practices as they're written into our Arizona science standards. The green that you're looking at on the dashboard right now, those are all cross-cutting concepts. So the cross-cutting concepts will be the lenses which we'll be using to really analyze and look at the phenomena that we will be looking at today. So our Arizona science standards, I'm sure if you're here, this is a level 2 webinar, but they were developed in 2018 and they should be implemented and being in practice this year, in fact. So when we're looking at our Arizona science standards and how they correlate to the NGSS, we are not an NGSS state. Our standards come from the same document as the next generation science standards, but they are not the same, you're non-NGSS state. So that means that if you were going to be pulling NGSS lessons, you really have to use the planning guide that is available on the ADE website just to kind of see, well, if this is a next generation science standards lesson, does it correlate to the lesson that I'm teaching in my class? So for instance, we're looking at 5th grade physical science standards, and you'll see on the left is our Arizona science standards. On the right, those are the next generation science standards. There is a partial alignment, but you'll notice that our 5th grade Arizona science standard is a 3rd grade NGSS standard. So you just really have to pay attention in terms of when you're looking at our standards and the NGSS planning guide. So that way you know that you're covering the Arizona science standards that you need to be covering in your classroom. And if it does say NC, that means that there is no correlation. It doesn't mean that you don't teach the Arizona standard. It just means that there won't be an NGSS standard that correlates to that. And then if you see an S by it, so instead of a P or an NC, if you do see an S, that means that there is a strong correlation between our Arizona science standard and a next generation science standard. So the lesson that we are going to be doing today, it is an Earth and space science lesson. And you'll see that it falls where our Arizona science standards are. It's falling underneath developing, revising, and using models based on evidence to construct explanations about different parts of our solar system. And then the purpose, the goal that we want our students to do in 5th grade is that we want them to be able to obtain, analyze, and communicate evidence to support an explanation. So all of this kind of feeds into the lesson that we are going to be doing today. And this is, you can look at this, it is on the dashboard and it is under the 3rd piece, going 3D with a GRC lesson. So the lesson is linked underneath that dashboard, as well as the main website for the GRC, and then the video that we will be watching in just a few moments. So the Connected Arizona Science Standard, it's a 5th grade Earth and Space Science, as I just mentioned to you. And what we are going to be really paying attention to are the science and engineering practices. We want our students to be constructing explanations from data that they will be deriving from the information that we will be sharing with them. We want them to be developing and using models. We want them to be asking questions about what they're doing and formalizing their own questions to research. And we also want them to take everything together and synthesize it and look at the information that they've collected in order to support their thinking. In terms of the cross-cutting concepts, we're going to be using scale, proportion, and quantity. And we are also going to be looking at what patterns we can notice and what we can make sense of from the information that we'll be working with today. So our Earth and Space Science Standards, this is coming directly from our Arizona Science Standards. So you can see that for us, developing, revising, and using models, and then constructing those explanations. And then highlighted are the patterns and the scale, proportion, and quantity. They are in bold because those are the lenses that you can use to take a look at these Earth and Space Science lessons. But really, there are other cross-cutting concepts that you could be using. It just depends on the lens that you want your students to be using and focusing on as you teach the lesson. And all of this background information, it's coming from a framework for K-12 science education. I had mentioned this, this document before. The NGSS is also built on the framework, just like our Arizona Science Standards. But I do want you to know that, if you don't already know already, that this background information is not meant to be a checklist that you're going through and you're saying, I'm teaching all these things. I'm done, it's meant to be kind of to give you some background information. And if you do want to see the whole document, you can download the Framework for K-12 Science Education, and it's free online. All you do is have to Google it, and then you just put in your email address and you can download it. So why are we using a GRC lesson? What makes these lessons so much better than other lessons? I love the GRC lessons because they're all three-dimensional science, which means that they include science and engineering practices. They include the core ideas of science that we want our students to be engaging with, and they include cross-cutting concepts as well. They are engaging for all of our students in making sense of phenomena, and they are structured so that students have the ability to gather that information, to reason, to produce evidence based on data, and to communicate their findings to make sense of phenomena. And they're not meant to do this by themselves, they're meant to do this with their peers, which is really awesome. And that's what's going to pop up during those group performances. So some instructional sequence, the gather, reason, communicate lessons, they're all based on an instructional sequence that creates the opportunity for students to make sense of the world around them. And I'm talking about things that they can and they cannot see. Lessons always begin with students gathering information, gathering those concepts that we want them to engage with, and ideas to reason with the phenomena that we are giving them. So when all of this happens, students are able to engage in these performance sequences and also communicate their findings with their peers. And teachers really serve as the facilitators as learning. We're not giving the students the information, we're helping them make sense of it. So phenomena-based science learning, why is it so important? So number one, as I've been mentioning, students engage with phenomena. They can gather information about what's causing the phenomenon and using evidence to support their reasoning. They can evaluate, analyze, and interpret data, which is from our Arizona science standards. These are the things that we want our kids to do. We want them to build explanations and develop models and even arguments and support their thinking. We want them to communicate their reasoning with a variety of modalities. They can do it in writing, they can do it in speaking, and they can always engage in making sense of phenomenon, not only in, but outside of the classroom, which is relevant to their lives, and it's related to what they're doing. And my favorite part about this is that it does really help students develop and foster their natural sense of curiosity, and they're wanting to know more. And it's not because you're telling them that they need to know this stuff, it's because they will generally be interested in what they are learning if they are in control and if they're being responsible for their own learning. So the first part of the GRC lesson, which is the gathering, we introduce the phenomena to students. And in this case, it is that I've noticed that some stars are brighter than others. So what we want our students to do in order to meet this goal is we want them to support an argument that differences in the apparent brightness of the sun compared to other stars is due to their relative distances from Earth. So that is our end goal here. This is what we want our students to be able to do based on the phenomena that we are giving them. So we are going to start off by watching a video, and this video is linked under dashboard item number 3. It's the Hawaiian Star Compass video. It is also available on the Going 3D with the GRC website. So if for some reason you bookmark that website and you come back to it, but you don't have the dashboard, you are able to find it on this lesson. So I am just going to stop share with you for a quick couple of seconds, just so that I can open up the other video and that I can share that with you. So this is the video when I launched this lesson, and I chose this lesson to teach my kids because it is very multicultural, and you'll see just from listening when they're talking about this, the Hawaiian Star Compass, and it also tied into our social science standards when we were talking about early explorers. So it just aligned really well, not just in science, but also what we were doing in social studies. So I loved it. So let me share this with you.
Now shared with Nainoa a technique used to determine direction, a traditional star compass based on the rising and setting points of stars in his region of Micronesia. Nainoa used this as inspiration to develop a system that would work in any part of the vast Pacific. This would eventually become known as the Hawaiian Star Compass, a system that divides the horizon into 32 equal houses. In this compass, Hikina points east, Hema south, Komohana west, and Akau north. The houses situated between the four cardinal directions are La, Aina, Noyo, Manu, Naalani, Naaleu, and Haka. The east and west portions of the star compass mirror each other, so that a star rising in southeast Manu will set in southwest Manu, or a star rising in southeast Aina will set in southwest Aina, and so on. Using Nainoa's system, it is possible to find direction by memorizing the houses in which particular stars live. Stars are most useful when they are rising or setting. As they move higher into the sky, it is more difficult to determine direction, and a navigator must seek out new stars near the horizon. Modern navigators memorize the houses of over 200 stars across the night sky. Nainoa's work to once again make the night sky relevant to Hawaiians inspired others to do the same. Years later, Hawaiian scholars at the University of Hawaii developed what they called the Hawaiian star families, Na Ohana Hoku Eha. These families divide the sky into 4 segments that run north to south. 3 of the 4 families can be seen throughout the course of a single night at any time of year. By memorizing the families and each of their members, a navigator can find the positions of all the other stars, even when some are obscured by clouds.
All right. Let me go back here, close this window. So after I showed my students this video, I read them a very short passage that's actually included in the Going 3D with the GRC lesson. So you will find this if you go to the lesson plan, which is Hoku, which is the Hoku lesson plan under 5th grade. But it was a nice time for me to read to the students, and so that they had a little bit more background information in terms of the Astrolab and the Hawaiian Star Compass. After that, and I also do want to stress that we have an hour and 15 minutes for this workshop, but of course, when I was doing this in my classroom, we're talking about a duration of time. So usually when I do a GRC lesson, it takes me about a week to get through all of the different components. And that week consists of science every day for 45 minutes. So depending on how much time you have for science and how familiar you are with the GRC with your kids, because in the beginning, when I was doing this lesson and even this year using GRC lessons, a lot of kids aren't used to the format of gathering information, reasoning through that information and communicating it. So it can definitely take a little bit longer. So you might end up teaching a GRC lesson for maybe a week and a half, maybe even 2 weeks. And that's really just depends on the pacing of your class. When your students get more familiar with this type of these types of lessons, then it does go by a little bit quicker. But on average, it does take me about a week to get through all of the components of a GRC lesson. So the next piece of this that I had my students work on is that I wanted the students to gather information And so we talked about observations, we talked about observing stars, and we launched it out with this first phenomena is that I've noticed that stars are brighter than others, and working with a small group, the students developed and they wrote scientific questions about what causes some stars to be brighter than others. Now, I do want to let you know that I didn't really give them very much information about this. I just wanted them to think about it and them to do all that heavy thinking in terms of what did they think caused some stars to be brighter than others, specifically how that happened and why. So why some stars appear to be brighter than others. So in a very small group on this call, and this is the part where we do ask you once you get in your breakout groups to turn on your cameras and please unmute yourselves. You will be working in a group of about 5 people, and we're only going to work on this for about 3 minutes. And you are going to be developing and writing some scientific questions about what causes some stars to appear brighter than others, and really think about how it happens and why. So you will also be just electing a speaker just to quickly kind of talk about what your group is coming up with. So your slide will look like this. And then you can find the link for the slides in the webinar dashboard underneath link number 5, where it says links for first breakout room gathering. And if you're able to go ahead and click on that, it's going to open up another window. You're going to see a screen just like the one on the left-hand side where it says group 1 and then names. And it's going to tell you exactly what I would like you to do, which is what I had my kids do. So as a group, you're going to be gathering information by just talking to the people on the call. And you're going to be talking about what you already know about what causes some stars to be brighter than others. And you're just going to write down 3 different thoughts, scientific questions that you have or observations that you've made, kind of leading back to the why and the how of why some stars appear brighter than others. So if you're able, if you've already clicked on that link in the dashboard number 5, if you could just write done into the chat, and that way I know that we are all on the same page. Awesome. So I see a couple done. Awesome. Awesome. All right. So I'm not going to stop screen sharing because I just want to show you what it will look like when you get in there. So when you open up this slide, it is going to look like this. And I do see some people in there, so yay. And depending on what breakout group you are in, so if you are in breakout group number 1, you're going to be working on slide number 1. If you're in breakout group number 2, you're going to go to slide number 2 and so on. And it's just going to be a quick discussion, 3 minutes. You're going to work with your group. Does anybody have any questions for me? Because if you do, I'd be happy to answer them or clarify anything if you want to write it into the chat box. I'm going to stop share real quick. All right, I think we're all good. I see lots of done. So I think we're ready, Rebecca.
How many rooms would you like?
There are 17 of us, so maybe 3.
I'll do 3. Perfect. And you said 3 minutes?
Yep, just 3 minutes.
All right, so I'll do 2 minutes with a 60-minute or 60-second warning. Hang on.
Awesome, thank you.
Okay, you got it. Okay, opening rooms now.
All right, so hopefully you were able to get down a couple of ideas. I'm going to go back to sharing my screen. And if somebody from group 1, so Amy, Paula, Lucia, Theodora, Lucille, or Laura, if one of you just might be able to talk about the why or the how. So what were you talking about? What causes some stars to appear brighter than others?
This is Paula from group 1. I'll go ahead and go. We were talking about the distance, the position, and the size. We also were trying to all navigate the Google slide, which is something our kids are going to have to do. And some of us were like, wait, we've only got a minute left. So being in that student position, it's understandable what they're going to go through as they're trying to do this as well.
Absolutely. And of course, you would give your students more time. But, all right, group number 2. I don't know who you are because you didn't put your names, but that's okay. If one of you could unmute yourselves and just tell us kind of what you were thinking about that.
I'll go. This is Bethany. And the two gentlemen that I was with, we just were talking about a little bit of, because of our experience as science educators, we kind of know. But, what might our students be thinking? And so how does the size of a star determine what color will a star affect on its magnitude? And how does the distance affect the brightness?
Awesome. Well, thank you. All right, and then group number 3, I worked with Michelle and Brisa, and we talked about very similar things. So the distance away that stars are affects the brightness, and then the size of the star can also affect the brightness. So we're kind of all thinking along the same lines, which is awesome. Your students may or may not think along these lines. I'm going to close the window and open up the main slide. So let me get back to the presentation. So this, I actually did this lesson last year during the pandemic when we were all virtual. So we will be looking at some videos that were taken. So I totally understand what you're saying about kids having to navigate Google and all that stuff. But this is what one group came up with. So if it is closer, then it is brighter, but if it is farther away, then it is darker. The color may help with how bright it is. And then somebody else had some thought about maybe it being, I think they meant to write cluster. But that is okay. And really the whole point of this gathering phase is to think of it as an opportunity that students have to learn from their group mates. And then all of these are shared whole group. So they're not only listening to their own group's ideas, but they're also listening to what other kids have to say as well. So it's a really great opportunity for kids just to gather as much information as they can from their peers. Great, so the next part of this is that we will be obtaining and evaluating some information that we will be gathering from an outside website, which is called Stellarium. And that is linked on the webinar dashboard under number 6. So if you go ahead and click on that link, you'll see where it says Stellarium website. And we want our students at this point to continue gathering information because we are still in that performance where students will be doing that. So if you're on the Stellarium website, it does look like this. You are going to want to click on the try the web version. There is all kinds of different things you can do. Kids can access this on iPads and all kinds of different devices, but we want to make sure that we're trying the web version. So please make sure that you go ahead and click on that. That way you can see it. And it is number 6 on the dashboard. And once you have opened up Stellarium, if you could just write done into the chat, and that way I know that we are all kind of on the same page here. Awesome. So I see done's. Awesome. All right. So I'm going to go ahead and continue. So I'm actually going to toggle back and forth here. So I have this website open. I'm going to click on the try the web version. So you should be looking at a screen that's very similar to this. The second breakout group, the second breakout room is listed on the webinar dashboard underneath link number 7. So in order to get to those breakout group slides, you do have to click on another link in the webinar dashboard where it says breakout room Google Slides, obtaining and evaluating information, because that's what this is all about at this stage. So once you open that link, and I do see a couple of people in there. So if you can, oh, awesome. So more of you are going there. We are going to be working in our groups to kind of piece together some information that we can obtain and then evaluate it as to why some stars appear brighter than others. So I'm going to kind of walk you through this using the very first example from group number 1. So the easiest thing to do is just going to be to highlight that, and then you're going to copy it. So Control C. And then if you go back to the Stellarium web app, you're going to want to paste that. So Control V. And then you click on this little magnifying glass. Oh, maybe that went away. Click enter and it will come up. And then when you click on it, it is going to give you a little bit of information, and it will also show you where it is in terms of in the night sky. What we really want to be gathering information from today is the magnitude and the distance. So the magnitude is going to be how bright the star appears, and then the distance, of course, is the light years to how far away that is. So when I'm looking at the magnitude, it is going to be 1. So I'm going to drop back over to my form, and I'm going to write the magnitude as 1. And this is a great opportunity to work with kids and really talk to them about decimals, because we will be working with some positive and some negative decimals. And so this is awesome. This is like math in real life here. So you're going to want to make sure that you put the magnitude, and just know that astronomers measure the brightness of objects using a scale called magnitude. So that is going to be your scale in proportion from your cross-cutting concepts. And then the lower the magnitude, the brighter the object appears. So if we have a negative number right here, if the magnitude was -2, we know that it is going to appear brighter to us. And I also did include this information on the last slide, so that way you can always go back in and check it out if you need to. But going back to the Stellarium website, I know the magnitude is 1, and I know the distance is 66 6400ths of a light year away. So when I go back to my breakout group, I can put that information right here, 66 6400ths. So really what I'm looking at is how far it is away in light years and how bright it appears. So I'm going to be looking for any patterns that I see within my group. Now, if you get lost at any time, you can go down to slide number 6, and it's going to tell you exactly what you should be doing. So you should be using the Stellarium app or a website. In our case, it is the website. And you're going to be thinking about the star's distance from Earth and its apparent brightness. And then same thing here, just please elect somebody to kind of chat about very quickly about what you shared in your group and what you found out from your group, from the data that you're collecting. And astronomers they measure the brightness of objects using the magnitude. So we do need to pay attention to the magnitude, and the lower the magnitude, the brighter the object will appear. Okay, so I'm going to go back here and I'm going to kind of skip along. So as a group, you're going to be obtaining and evaluating information. And I think I'm good. So hopefully you are there. I know a lot of you are already there in the breakout group, and we'll probably Rebecca, probably 4 minutes on this one, 3 minutes maybe.
I'll do 3 with a 60-second.
Okay, perfect. Thank you.
You got it. Okay, rooms are open.
All right, thanks. Okay, so welcome back. And of course, you would give your students a lot more time to do this than just a few minutes that we had together. And if you are interested in teaching this lesson, which I hope that you will, if you are teaching a 4-5 or a 5, there is a lot more stars that you can have those kids work through to gather even more information. So it's awesome. All right, let me go back to sharing my screen with you. And if one person from group 1, just if you noticed anything, what do you notice? What do you wonder? What were some of the things you talked about? If somebody could share with us, that would be great.
This is Paula. I was in group 1. We had just enough time to fill in our chart. We didn't have any discussion time.
Okay. Totally fine. Totally fine. All right. And I wish we had longer. Let's see if group 2, did you have enough time to talk about or any patterns that you noticed?
No, 2 of my group mates were busy filling in the chart. We didn't talk about patterns. So I apologize for that.
Okay, no worries at all. All right, group 3. So I was in this group and we also were busy filling in the information. But one thing that I do want you to notice, and I'll just use Sirius as an example, is that the lower the magnitude, the brighter the star is. So when you look at the distance in light years that Sirius is away from Earth, and then how bright it is, that does totally feed into what we want our students to think about the brightness of stars and how close or how far away they are from Earth. A star like Betelgeuse, which is super far away, right? 497 light years away. Look at the magnitude of that, right? So anything that is, the lower the number, the brighter it is. So it would be an interesting conversation to have with your kids and just looking at the patterns, even if you only pulled out Sirius and Betelgeuse, about what they notice between the magnitude and then the light years. All right, let me go back here. So my students did have a lot more time than you had just to kind of go through and collect some information. So there are a lot of good conversations that can be had. And if you do use the lesson available on the website, then you'll see that there's a lot more stars that your students can work through. Some of the questions that you can ask your kids, and especially because you want them thinking about those cross-cutting concepts, the patterns that they notice, can they use the pattern for an explanation? From this pattern, I predict that. And all of these are also linked on the webinar dashboard, and they're under tool number 8, which is the STEM teaching tool number 41. So awesome prompts that you can use if you want your kids to start thinking about these. So putting it all together, as I talked about, so a star with a magnitude of 49/100 would be the least brightest compared to another that was negative 26 82/100. So by comparing the brightness of the stars from the sun, students would see that the brightest star, which is our sun, is closer than any other star. It does not mean that it is the brightest star in the sky. All right, so modeling, this is our 3rd performance. And so we are going to try out some modeling ourselves. So for the modeling, if you could go back to the webinar dashboard, the links for the modeling are under tool number 9. So if you could just check that out. If you're in group 1, you're going to be in group number 1. If you are in group number 2, you'll be in group number 2. And really what we want our students to do, and what I would like you to do, is I would like you to develop a model to show how the scale of the distance. So if it's closer in light years, is it going to be brighter? Or is it going to be dimmer than another star? And how the distance affects the brightness of the stars. So you are going to be doing that in Google Drawing. And then after we get done with this part of it, and after you've created your models, then we will watch some students and we'll see how they created their models. So I am going to stop share. If you could, could put done into the chat box if you're looking at the webinar dashboard 7, which is a link to 9, I'm getting 9, links for the third breakout group, which is modeling. If you could just write done, awesome. And then Rebecca, I think we're gonna work on this for about 5 minutes, if that's okay. And you won't be able to finish it, but at least you'll be able to kind of, you know, play around in Google Drawing and maybe get some stars on there. No one needs to share out. I can just quickly share what everyone has done in the breakout group. So about 5 minutes, Rebecca.
Okay, opening.
Awesome, thanks. All right, so I'm just gonna go through and just click on the models. You don't have to say anything. I just kind of wanted to see what good things you guys were working on. And once again, your students would be working on this for a while, definitely not as much time as you had. So this was one of the groups, so awesome. And if you've never used Google Drawing, it's you just have to get the hang of it, but kids love it. All right, so that was group number 1. We're working on it. Group number 2. There is some more. Oh, awesome. So you listed the stars and you're using the information from that data table. So awesome. Awesome. All right. And then group number 3, we were working on this. So we had some models. So this is what you want your students to be engaging with. You want them to kind of synthesize all that information. You want them working as a group as they're gathering and reasoning through that information. Yeah, the awesome start. All right, so let me close these out. So I do want to show you some video that was taken from my classroom, and you're going to see that the students had the same task that that you're working on. If you want to see a longer bit of the video, they're on the dashboard under 10 and 11. But I'm just going to show you just a few minutes from the modeling part of it, and then a few minutes from the explanation part of it, so that you can see this real life 5th grade virtual pandemic learning, working through the GRC lesson. You're going to love it. All right, so here we go. Share screen. Here we go. Finish. Okay, so walk me through what you added and what it means. Walk me through your model from start to finish.
So basically at the beginning, why we thought that stars appeared brighter than others was because some of them are closer to Earth than others. As you can see, there's a star that's 5,000 miles away, and it's closer to Earth, so that it'll probably be more visible for us to see since we live on Earth, and then the 6,000 miles is further away, so it won't appear as bright. If you look directly at the sun, it's going to be very bright. If you were like super duper far away from it, it's not going to be as bright as looking directly at it when it's right in the sky above you.
Okay.
And then also there's a star cluster. It's circled, and when stars come together, they also seem to be brighter because it makes one big bright light when stars all come together.
So this student may or may not be right, but what the student is doing is explaining the science as they know it, which is a beautiful thing. Like, I'm not giving them the answers, I'm letting them work through it. If you watch the whole video, which we won't watch today, the video that I've linked, you'll see that the student does give a misconception. And I actually add that to my questioning board because that's a great opportunity to go back in and take a look at some of the beliefs that the students hold. And it really does tell you a lot about what they know. So let me advance this, and I think
In between these two stars,
all right, so now this is the final explanation after they're done with their models. This is a different group, but I just want you to see after the students have gathered information and they've reasoned it through it, now they're communicating it with the whole group. So this is done all together.
star may not seem as bright, but it is brighter than the first.
And then finally, we have our LEDs that's giving off quite a bit of light. And it says, and this star may seem the dimmest of all three, but it is the brightest of all of them because it's giving off a lot of light, but it's so far away that we can't see that it's giving off more light. So if we were to go like in between these two stars, the two brighter ones, we would find that the further away one is brighter. Same with the other two. And if we were to take out the middle star and go right where it was, we could see that the other star was brighter.
Okay, thank you. Does anybody have any questions or comments for this group? Group number.
I have a wonder. I have a wonder.
Okay, tell me your wonder.
I wonder how light from the city affects how we see stars. Because I've noticed that in an urban area like Tucson and Arizona in general, we can't see stars as much as people in rural areas like the country in Annabelle would.
Okay, so if I understand you correctly, if I've written this down correctly on my Post-it note, you're saying, I wonder how light from the city affects stars. Okay,
Yes.
perfect. So now I have 2 new questions for our wonder wall. So now there's a total of 3. Perfect, thank you so much. All right, so all of the groups were able to share that information. We went through, whole group, every kid was working, every kid had the opportunity for input. They did elect one speaker, but if you do want to see all of them, like they're all linked on the webinar dashboard for you to go back in at your own leisure and check those out. All right, we're almost done. We're almost in home stretch. So let me just, share this. So the last part of that, what you just saw was the 4th performance. And so really, just to kind of summarize, students work together as a group to construct an explanation for how the scale of distance to the stars affects their brightness. So all of the groups had the same performance objective. They did it as a group and they shared it out whole group. So that way there's equity in education, science education. Everyone is listening to this. Everyone is engaged with this. And then they actually had 5 minutes to plan it and then make modifications. So they were able to actually go back in and change their models, which is really what we want our students doing. That's what scientists do. And that's one thing that's really hard to get the kids thinking about is that when you make a model first time out the door, you're going to keep going back in and you're going to keep revising that model because that's what scientists do. And it's okay if you don't know, and it's okay if your model's not the best model. When we get information, we gather it and we communicate it and we reason with others, that's an awesome opportunity to take that new learning and integrate it into our models. That's what we want our students doing. Sorry, I'm gonna skip that. So then afterwards, we had a class discussion. So everyone has shared, we had a class discussion. We looked for just overall, like what everyone shared, what did we think about it? What questions did we have? If we could clarify anything. It was very student-led. I'm facilitating their thinking, but I'm not putting words in their mouth by any means because I want them to think through it. I want them to come up with these great ideas. And then I had my students create a Post-it note, which is what I'm going to ask you to do because we do still have a little bit of time. So if you check out the webinar dashboard and you go to link number 12 where it says Jamboard for Reasoning, if you could open that up on your screen, and when you are able to do that, if you could just write done, and that way I know that we are opening up the Jamboard. Awesome. Awesome. I see lots of, we're getting there. Awesome. Now I'm going to go back here and I'm going to click on the Jamboard link. So this was before they worked on that individual performance. I had my students just make a Post-it note. So, and this is specifically answering the phenomena that I'd presented that is in the lesson all along that they've been gathering information about, reasoning, and now we're still communicating. So I've noticed that some stars appear brighter than others. Why do you think this phenomena occurs? So I'm going to have you do the same thing that I had my students do. And if you've never used Jamboard, it's really cool. If you go over to the little sticky note right there and you click on it, And what I usually have my students do is I have them write their name and then I have them write an answer. And that way I know just from looking at it that this is what the student thinks. And I also know if the student doesn't do one, because then I can't check off their name when I'm taking notes and kind of assessing how they learn. So if you would take a minute, and I will stop screen sharing with you. And if you could just add a Post-it note, are you able to open up the Post-it notes on the screen? Thumbs up if you're able to open up the Post-it note.
Yes, we're good. I'm good.
Awesome, awesome. So if you just want to, and just think about, you've noticed that some stars are brighter than others. Why does this occur? And if you could just, and you're kind of limited to what you can type in there. I'm going to stop screen share just so that you can make that bigger. And if you could add a note, that would be great.
Robin, clarifying question. The question they're answering is on the Jamboard, correct?
Oh yes, absolutely. So the question that you're answering at this point, so we're still communicating our findings. I've noticed that some stars are brighter than others. Why do you think this phenomena occurs? So why do you think that some stars appear brighter than others? And if it's okay, if you're having a computer problem, that's okay. We're going to check it out in just a second. And I also linked it on, if you go up, like if, for instance, you were to run out of room when you're doing this with your class, you can just, if you go up to the top of the screen, there's the next arrow, and it's actually linked on 2 slides. So that way students don't say that they ran out of room. It is on the yellow Post-it, absolutely.
So Robin, which link are we in? What number? Someone has a question in the chat.
It is the webinar dashboard, link number 12, where it says Jamboard for reasoning. And it says Jamboard link. And I would totally, and I know that it's, I think, Kathleen, Jim, I'll be more than happy to stay on the call with you after the webinar is over and we can walk through how you would access that. All right, I'm going to give you about another 30 seconds. All right, I'm going to go back to screen share. Great, so this is the awesome work that you have been working on, and it's so nice. I really use this to guide future discussions and then also to kind of gauge if I need to go back and reteach something, if I need to go back in and enrich something as well. And I do want to show you when I go back to the main presentation. So these are just some of the answers that my students had put on here. And I can tell, I can kind of gauge which students are really getting it and which students that I would have to go back in and kind of work with a little bit longer. But I definitely, it's very interesting when Jamboards are kind of put together because it's a meeting of the minds. So it's a great resource to use. And then the very last part of this, which you won't be doing today, but all of the details on this are also available on the Going 3D with the GRC site. At the very end, like after we've gathered information, we've reasoned, we've communicated. Sometimes we go back to gathering depending on where we're at. Sometimes we go back to reasoning. So sometimes we just keep going back and forth. The students individually, now this is on their own, will develop an argument for how the apparent brightness of the sun compared to other stars is due to the scale of the distance from Earth. So that's really what I want them getting at, is kind of putting all together that information and being able to explain what they've learned in correlation, in relation to the sun. Right, and the best part, one of the best parts, another part about the GRC lessons is that it gives you the formative assessment rubric that you can be using. And it will tell you exactly how you know if your students are proficient. So if you take a look at the left-hand side, it kind of gives you a little blurb as to what they would be writing about or even drawing a model. sometimes I actually have them do both because I love the models. It tells you the student has full understanding what you would be looking at, partial, and then even limited understanding. And then it does give you some suggestions to act on that understanding. So if students are exhibiting partial or limited understanding, then you would go back in and you would give them more information, readings about astronomical units or even light years. That way they can really break down the magnitude and the idea of a magnitude and the idea of a light year. And then you can be working with these students in small group and you can be giving them these questions. And then if students fully get this, then you can have them research different formulas for magnitude and then apply those formulas to brightness and or distance, or you can just have them research some other stars maybe that they would see in the Tucson sky right now. And you can kind of have them do or Arizona sky, I should say. So there's lots of different things you can do. You can take all of that information and you can make a beautiful graph with it, which is awesome. All right, Rebecca, I'm going to turn it over to you. I won't stop screen sharing, but if you want to talk about it.
Sure. So we are at the end of our time together, but we will stay on for questions. Don't worry. Just as a reminder, it takes me about 24 to 48 hours to enter attendance, and you will receive a certificate the minute I mark you completed, and to remember that you are in charge of printing your own certificate from your ADE Connect account. And I will send you a follow-up emails. That way you know I've done everything. So thank you to Robin for being an amazing facilitator, sharing your knowledge and your lesson and your class with us. Thank you, thank you, thank you.
Thanks for sharing your time with me. I know it's a Tuesday and